Hi, class. Today is Monday, the 20th, and we got a lot of stuff to do today. Okay, so let's go ahead and put our first and last name on our at the top of our packet, please. Put your first and last name at the top of your packet. You are gonna need this sheet, so please make sure that this passes out this sheet. You are gonna need this sheet. Okay. All right, and that's literal equations. It's like a little half sheet. And if you can't find it, no worries. I'll be writing out these anyway because you're going to do the odd today and you're going to do the even tomorrow. Okay, and we're going to put this in our interactive notebook. We're going to put this in our interactive notebook. I haven't decided whether or not we're going to submit this online. So for right now, we're going to put this in our interactive notebook. Today, even tomorrow. Okay. All right, so here we go with what is due this week. The warm up is due this week, as usual. Each day is worth 25 points. The homework is due this week. Our resources, of course, is going to be the daily videos. This is also done in class, okay? Um, Homework the same. There are going to be some help videos that I'm going to put out there for this week. Today, I'm going to show you in the daily video how to do the homework for tonight. And if I need to make another help video for the homework, then I'll make sure to include that tomorrow. Okay. All right. So, what else is due? Oh, we have a quiz this week. I lost my train of thought that quickly. We have a quiz on literal equations this week. Um, and f of x, solving f of x in function notation. All right, which are going to be very, 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 very easy. We're doing key terms, but I don't know that you're going to feel comfortable by the end of the week to have a quiz on that. So I'll just, if you find that to be very easy, then I'll put that in there. If not, then we'll see it on our unit test, okay, or um, the following week, okay, because we're almost at unit test mode. We're almost finished. We need another week or so, and then we'll be finished with this unit. All right. So today we're gonna write down what our EQs are. Then we're gonna write. We're gonna work on our warm up. I'm gonna show you how to do some of the problems in the homework. Go over homework. I said go homework. And then we're gonna write some notes on literal equations. We're going to do some notes on literal equations, and then we're going to do some practice problems that I showed you a minute ago. All right, so our homework for tonight is going to be set 5A problems, okay, in the packet, of course. And I don't know what's going on with me, this right here. And if you did not finish the practice problems, the literal equations, then you need to do the odd problems 1 through 19, and they need to be in your interactive notebook. Interactive notebook. Okay. All right. So let's go ahead and write down our essential questions. The first essential question is, how do you solve, describe how to solve literal equations. Describe how to solve literal equations. Number 2, what is a function? What is a function? What is a function? Number 3, describe how to write equations in function notation. Describe how to write equations in function notation. And let's see, describe how to solve f of x problems. Oops. Describe how to solve f of x problems. And if we have time, the fifth one we'll do. If we don't, it's okay. I won't push it. But this is being overzealous. What are the key features of a graph? This is overzealous. If we don't get to it, guess what? It's okay. What are the key features of a graph? Okay. Pause if you need more time to write. Okay. Let's look at the warm up. All right. I need you to pause the video at this time so that you can work on your warm up independently, and then we'll go over it. Pause for the calls. Okay. Let's look at it. Here I'm only gonna do, because most of this you know how to do. Okay, estimate, you know how to do that. Please make sure that you show your work. Approximate, you know how it's the same thing as this. All you're doing is rounding this to the nearest whole number. You know how to do that. Which one is it closest to? And this one, this is different wording, verbiage. So I'll do this one real quick. You have 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5 is 25, 6 times 6 is 36. So it's between those two. The two whole numbers that is in between, or the two perfect squares that is in between, is the square root of 25 and the square root of 36. Is it closer to 25 or is it closer to 36? It is definitely closer to 36. So since the answer to square root of 36 is 6, we're going to approximate this to 6. It's closest to 6, okay? It's about. The squiggly lines mean about 6. All right? Use the decimal form. Please make sure that if you use the calculator, that you put the calculator back. But look at this. You need to change all of these to decimals, okay? And then pick the one that is the greatest value. This one you hadn't seen before. Write this as a simplified fraction. It's a couple ways that you can do this in your calculator by typing this in, press math, enter, press the math button and then enter. Or since one number is repeating, your bottom number is going to be 9. Okay, it's going to be 9 on the bottom. Your numerator is the number that's repeating. So now all you have to do is reduce this. When you reduce, you're going to divide both the top and bottom by 3, and that's going to give you 2 over 3. This is your fraction. So even if you had 0.5 repeating, the answer here would be 5 over 9. Okay? If you had 1/3 repeating, the answer for this would be 1/3 over 99. However many numbers are repeating, that's how many nines you put as your denominator. And then make sure that, of course, you reduce. All right. All the sets that this fraction belongs to, it's a real number. We know that. It's going to be rational because it's written as a fraction, and that's all it can be, is real and rational. All right, which one is larger? Look at this one. Compare. How much larger? Oh, sorry. How much larger is this one? Remember what we did before? We're going to divide to figure out how much larger one is from the other. Okay, please make sure that you show your work on this. Do this on your own, okay? Make sure it's written. Make sure you figure out how much bigger this is than that. Please divide. Don't forget to put this in parentheses, okay? All right. You can pause for the calls to make sure everything is 100% completed. I only went over some of it, but you need to make sure all of it is completed. If you have more questions, comments, or concerns, you can jot those down and ask me tomorrow. Please make sure that this is done. Now let's go through the homework. Let's go over your homework. please make sure that you write your homework on a separate sheet of paper. I'm getting ready to take out a piece of paper now. Okay, my homework. Okay. When you are doing your homework and you take out a separate piece of paper, go ahead and do that now because I want you to go ahead and have at least this part done. So if you need to pause the video, please do that. We are going to write here. This is week 5. This is 5A. We got Monday. All right. Okay, good people. We're going to do this one together. We're going to do number 1. You should be able to do most, if not all of these. The rest of these you should be able to do on your own. But number 1, you've never seen before. So I need to do that one with you. Okay. And so let's look at this one. It says the population of Gondor in 1990 was about 24 million. So that was the starting population. Okay, that's how much it was in this year. The following information is the Census Bureau's annual estimate of change based on the current trends. Okay, so this is what they predict how the population is going to change each year. Okay, so these are their predictions based on the information they collected in their census. A Census Bureau is a survey that goes out every 10 years to update the population in a region, okay, in cities, states, in our country in general. So that's just how we collect information. It's called a Census Bureau. Okay. So let's see here. Trends, based on the trends, this is what they found. The births in this particular region, this population in 1990, they're saying that this is how the population changes. Births each year will equal about 1.3% of the total population. Okay, so it's 1.3% of the total population, whatever the population is that year. Deaths every year will equal about 0.5. So births adds to the population, where deaths take away from the population, because as people die, you subtract them from the population. Immigration, people that are migrating into that area is about 0.4 million people. So that adds to the population as well. So what they want you to do is write a next now equation. I'm going to show you how to do that to find the population for 2010. Okay. So this is a challenging problem here. So I'm going to show you how to write a next now equation for a problem as such, because you'll have to do some problems like this on your own in the near future. All right. So let me walk you through that. The first thing that you're going to do is write starting at. Okay, so your starting amount is always the first thing that you need to write for next now equations. And your starting population is 24 million. So we're starting at 24 million. Okay, that's your starting at. That's how much you automatically, that's the starting population. All right. So now the next thing you write is the setup for the equation, which is next equals now. So your next number, this is how you write an equation. Your next number is equal to whatever your now is. Your first now is going to be 24 for 24 million. Okay, is your first now. And what am I going to do to get the population each year? So let's look at what needs to be done. Okay, the first thing that needs to be done is adding 0.3% to the population, and then subtracting 0.5 from the population. Well, let's combine those amounts together, honestly. So we'll only have to do percent one time. So out here to the side, we got 1.3% that's adding But from that, we can go ahead and subtract the point five, right? Because those are the amount of people that are dying. Doesn't matter like the names per se, but that's you know that's what we're gonna do to combine the percents together. So we're only having to do 1% versus having to do the births and then turn around and do the deaths. So let's combine those amounts. 1.3 minus 0.5. And look at what that gives us. That's 0.8. Okay. So 0.8 percent includes both the deaths and the births. Okay. It includes them both. All right. So now what do? All you do is you're going to multiply the percent, and it's 0.8%. So you're going to change this percent to a decimal. You by moving the decimal over two places to the left. So this is going to be 0.008. Okay. So times 0.008. And this amount right here tells us the amount of people that are going to be added to the population. So we're going to take this and we're going to add it to whatever the now is, which the first now is going to be 24 million. Oops, let's just put now. That's where it is. So this included the births and the deaths, okay? And now we took care of the percent. So all we did was we took the births and deaths combined and multiplied it times your now. And so all you're going to do now is you're going to add the immigration. So the people that migrated to that, and the number of people that migrated to that region was what? I forgot. 0.4 million. And this is going to be the equation. Okay. So again, we combine the percents together, both the deaths and the births together. That gave us this percent right here, which we changed to a decimal. So we're going to multiply this decimal times our now, which our first now is for that year, the starting year is 24 million. Okay. Then after we find this amount just tells us how many people to add to the population. So we add it back to the 24 million. Then we have to add on the immigration. So we add 0.4 million for the people that migrated to that region. So that's how you do number one. And no worries if you don't get it right now. We're going to see that a bunch of times. So you'll get it at some point. Don't get frustrated because you don't get something the first time. It's perfectly okay. All right. So we have the square root of 38 plus the square root of 55 plus the square root of 95. So you're going to round this to the nearest whole number, okay? Round this to the nearest whole number. So what two whole numbers, what two perfect squares is this in between? Or when you have the square root, you type in the square root of 38. Look at what that is. That's about 6. So this is about 6 plus the square root of 55. That's about 7 plus the square root. Oops, sorry, y'all. The square root of 95. No, I didn't type that in right. Sorry. The square root of 95, which is about 10. So now you just add these numbers together, and that's gonna be your answer. Okay. Let's look at number 3. Which number? It says which number is irrational. So you're gonna choose the number that's irrational there. That shouldn't be difficult for you. Number 4. This says the height of the candle and the number of hours that it has been burning. The independent variable. Your independent variable is always your x values or your input values. Okay. Um, let's see, the height of the candle and the hours burned, it's asking you for which one is your X value. So is it the height of the candle or is it the hours, the number of hours burning? So this is how a lot of times you have to think logically. What would I graph along the X axis? And then what would I graph along the Y axis? The height of the candle and the number of hours. Well, the height of the candle, I would graph here. Height of candle. And this is number 4, by the way. And hours, what is it? Hours burning? Number of hours. Yeah. Number of hours I would graph along the x-axis. So this is my independent variable. So my independent variable, or my x values, is going to be the number of hours. My dependent variable is going to be the height. All right. Why, Miss Reyes? Because look, my independent variable is unaffected by anything. The hours are going to increase regardless. It's unaffected. Hours is not affected by anything. It's not going to pause. It's not going to go backwards. However, the height of the candle is dependent on how many hours it's burning. So your height is depending on the hours that it burns. So it's going to keep decreasing depending on how long it's actually burning. Right? So that is dependent. All right? So that's the reason for that. Number, let's see, 5 you should be able to do on your own. Number 4 you should be able to do on your own because all you're doing is substituting there. The wait a minute, wait. Yeah, you should be able to do that on your own. Okay, the rest of them you should be able to do this on your own. Okay. All right, so I'm gonna stop there with that. If you have more questions, however, feel free to text me and let me know. Okay. All right, and I don't mind later on making a separate video if that's what you need. Okay, pause for the cause. Please take out your interactive notebook and make sure that you have this available. All right, you should have your interactive notebook out. And we are now on, let's see here. The last page that we did was page 21, solving. We did our solving inequalities page. Okay, so now we are working on literal equations. Okay, so what page was that? And that was page 21. So this is going to be page 22. Okay, so this is Q1, page 22. Please pause the video if you need to, okay? Please pause the video if you need to. The name of this page is literal equations. This is not going to be nowhere near as bad as you think it is. It's really not. This is going to be quite easy, okay? And if it's not, then of course I will be here to help you, okay? All right. So, what is a literal equation? What is a literal equation? Literal equations, let's write this down. Literal equations are equations with more than one variable. That's what a literal equation is. A literal equation is an equation that has more than one variable. Super simple, right? It just has more than one variable. The big question is, how do you solve it then? If it has so many variables, then how do you solve it? How do you solve a literal equation? Super duper good question. Because it has more than one variable, to solve a literal equation, it first must tell you which one of those variables you're solving for. And you're going to use algebraic principles to isolate the variable? You're going to isolate the variable by using inverse operations, okay? So to solve literal equations, you're going to use inverse operations. That's it. Use inverse operations to isolate the variable you are solving for. Okay, so it's going to tell you, it's got all these letters in it or variables in it, and it's only going to tell you to solve for one of them. And that's the one that you have to get by itself. You treat the other variables as if they're numbers, okay? You treat the other variables as if they're numbers. You're going to use inverse operation to only isolate the variable that they tell you to solve for. That's it, that's all. Okay? All right, so we're going to go back to, look, we're going to go and do these odd problems here. Okay, we're doing the odd today. All right, and do you see the number that's in the parentheses? This is the variable that they want you to solve for. This is the variable that they want you to solve for. So I'm going to do those, and the ones I'm going to have you do a couple on your own, okay? I'm going to have you do quite a few on your own to see what you can come up with. If you don't finish the odd ones, then you need to complete the odd ones for homework, okay? Along with the set A problems, 5 set A problems. Don't forget to do those. That's a given. So let's do this. Number 1. And remember, we're doing the odd first. We have P is equal to capital R, capital I, capital T. Okay, and here we're going to solve for T. That means we're going to get T by itself. All right, so look at what is on the same side as T. The I, the R, and the I and the R. How is I and R connected to T? It's connected by multiplication. If you don't see an operation between numbers or variables, it's automatically multiplication there. So the only way to detach the I and the R, or to remove the I and the R, is to use the inverse operation of multiplication, which is division. So you want to get rid of both I and R. So we're going to divide both sides by IR. And that's how you eliminate that. So on this side, you have, or move it, sorry. On this side, you have P divided by IR. Bring down the equal sign. And on this side, I divided by I is 1. R divided by R is 1. So this is gone. This is 1T, or just T. So this is my answer. Or I could say T is equal to P divided by IR. This is my answer. So you can see it either way. Okay? All right. Let's try number 3. Remember, we're doing the odd ones, okay? So we have Y is equal to 5x minus 6. And here it says solve. You see in the parentheses, it has an X. So it's saying solve for X. Solve for X. Okay? All right, so now in order to get X by itself, you need to get rid of the 5 and the negative 6. So think about it. How do I get 5 and which one do I get rid of first? Remember, to get rid of anything, you can add or subtract to remove. So I'm going to get rid of the 6 first, the minus 6. The opposite, or the inverse of subtracting 6, is to add 6. So we're going to add 6 to both sides. When I add 6 to this side, I get Y plus 6. I bring down my equal sign. This is gone. I'm going to bring down the 5x now. Okay? So now, how do I isolate x? How do I get rid of 5? What's the operation that is between 5 and x? Multiplication is. So the inverse of multiplication is division. So I'm going to divide both sides by 5. So now what I get is Y plus 6 divided by 5. Bring down my equal sign. 5 divided by 5 is 1. So I'm left with 1x or just x. The other way to write this is x is equal to y plus 6 divided by 5. This is the other way there. It's the same thing, okay? It is the same thing. All right, if you have questions or if you need to pause for the calls, just pause the video. If you have questions, jot your questions down. You can ask me tomorrow or you can text me, okay? All right, move this over. Probably need to do it this way. Number 5. Number 5. Number 5 looks tricky, y'all. It says x plus y divided by 3 is equal to 5. And here's asking us to solve for x. That's the number, that's the variable. See right here? That's the variable that's in the parentheses. So this is what they want you to solve for. All right. So in order to solve for x, work on this side here. We got to get rid of the y and the 3. But what do we have to get rid of first? We have to get rid of this 3. You can't do anything until you get rid of that 3. You can't do anything else. This is division. So 3 is attached to x by division. So the only way to get rid of 3 is to do the inverse of division, which is to multiply both sides by 3. Okay. So when you multiply this side by 3, this is gone. And I'm left with x plus y. Bring down the equal sign. 5 times 3 is 15. Okay. So now what do I do to get x by itself? I got to get rid of this y. This is a plus y. So I do the inverse of adding y, which is to subtract y on both sides. When I subtract y here, this is gone, and I'm left with just the x now. Okay, bring down my equal. When I subtract y here, I say 15 minus y, because remember they're not like terms, so I have to just bring it down. And this is going to be my answer. Okay, that is number 5. All right, pause if you need to. Number 7, this is number 7, and it's saying solve for y. All right, so let's look at number 7. Number 7 says ax plus by is equal to c. And we are solving, it says solve, I don't know why I say solving. Solve for, what does it say? Y. Okay, so we're getting y by itself this time. So work on this side because this is the side that has y on it. That's what you're solving for. So you're isolating y. So first thing I do is move anything I can add or subtract. Look, ax, I have to move it. This is a positive ax. So to move a positive ax, you're going to subtract ax. Why, Miss Reyes, are you deciding to move the ax first? Okay, because b is attached by multiplication, and you do that last. Okay, get rid of anything you can add or subtract. Move that first. So we're going to move ax over here by subtracting ax. So now this is gone, and I'm left with by. Bring down the equal, and I have c minus ax. Okay? Now we got to get y by itself by getting rid of this b. Remember, if you don't see an operation between a number or a variable, it's automatically multiplication. So the only way to undo multiplication is to do the inverse, which is division. So you're going to divide both sides by b. So b divided by b is 1. So this is 1y is equal to, and on this side you have c minus ax divided by b. This is your answer. Y is isolated now. Okay. All right. Let's do another one. Let's do number 9. Okay. Number 9, you have v is equal to L times W times H. Okay. This is saying solve for L. Solve for L. Okay. All right, so look at this. What operation is between these is multiplication. The inverse of multiplication is division. So to get rid of WH, which is being multiplied, you have to divide both sides by WH. So here you get V divided by WH. Bring down the equal sign. And here, this is gone. And you're left with L. So L, which is what you're solving for, L is equal to V over WH. You can write it like this, or you can keep it like this. They mean the same thing. Okay? All right, pause if you need to. Don't forget that you can do that. Okay? All right, look at these. Look at these. I'm going to zoom in a little bit. So if you don't have your paper, I need you to go ahead and finish up these right here. Okay, need you to go see if you can do these on your own. Okay, I need you to write these in your interactive notebook. You're doing the odd. Some of you might want to go ahead and do the even. That's whatever. That's fine. I'm going to be checking. Tomorrow, I'm going to be checking for these along with your homework. So please make sure that this is in your interactive notebook, okay? I hope you have a wonderful day. Please thank our wonderful, wonderful um, sub, and we just appreciate people that will step in and sub when we just can't be there. All right, hope you all are having an amazing day. Miss you so very much, and I will see you tomorrow. Thank you. Bye.